Hi guys, Miss Griffin. We're looking at Unit 8 Skill 1A. So it's 1A because we're breaking apart exponent rules into two skills. So today we're going to start with some easy ones related to exponents. And so your central question right here says, what rules can be applied for simplifying with exponents? So there's quite a few of basic exponent properties or laws that you have to know in order to be successful with this stuff. So the first thing we see is when we have multiplication with these expressions that have the same base. So those exponents, m and n, end up getting added together. So it becomes x, that same base, to the power of m plus n. We add the exponents when multiplying numbers with the same base. So we're going to apply that to the next couple examples before we move on to our next rule. So when I look at this, I look for any coefficients first. So I see the 4 and 2, so 4 times 2 gives me 8. And then I try to write these other things in alphabetical order if possible. So I see a J, I see an H, I see a J, K, and H. So I'm going to go focus on the H's for a second. So H to the third and H to the second. Really what this is saying is H to the third times H to the second. So that makes H to the fifth in total. And all I'm doing is adding those exponents. H, and then next thing in the alphabet are these J's. So this is J times J. J times J. No powers on them, so that means they have an invisible power of 1. So 1 plus 1 turns into J to the second. And then the last one that's there, it's kind of tough to see because of all my colors already, but there's that K. K was by itself, there was nothing to multiply it by, so it just stays. So we're going to apply that to the next several questions. So I'll walk you through one more, and then hopefully you'll be able to try one on your own, or two on your own. So we start with, again, the coefficients. 4 times 5 makes 20. Then I'm looking for alphabetical order. If you want to just write it out first by doing like each set of letters, like P comes next, P is over here, then we could rearrange afterwards if you prefer. So that would be P to the third because it's power of 1 plus power of 2. And then n's, I have n here to the third and n here to the invisible first. So 3 and 1 gets added to become n to the fourth. And then m is left over as its own thing, so it stays as m squared. And then now here I can rearrange. We've got 20, and then alphabetical order puts us in m squared, n to the fourth, and p to the third. All right, so take a second, you try these next two questions, and then check your answers. All right, so I have my answers here. I'll talk through them real quick. We had this 4 times 4 to make 16. We had q to the first times q to the first, and again, the power of 1 get added to make q to the second. And then we have p to the second times p to the second makes p to the fourth. And then r to the fifth times r squared makes r to the seventh. And some of you might have already rearranged this to give you 16 p to the fourth, q squared r to the seventh, if you put them in that alphabetical order. And then the last one here, we have 5 times 2, it makes 10. A squared times a to the third. And again, what we're thinking about as we do this is taking those exponents and adding them. Oftentimes you'll see me doing this little image in each of them. I didn't show it here because I didn't want it to be too crowded, but we just take the exponents and we add them, and showing that we're adding them helps us remember where it came from. Okay, so we have 10a to the fifth, b squared, c to the seventh. And now we're moving on to the next page. So on this next page we have another rule here. Negative exponents are not our friend. So if you ever have a negative exponent, we need to change it. It needs to move location, right? So here what we see is this b to the negative n is technically over 1 right now. And it gets dropped down and becomes a positive n. Okay, so what we do is we call this cross the line. And change the sign of the exponent. The same thing would occur if it's down in the denominator. That negative n as the exponent forces us to move location. So now it crosses the line, it comes up above that division line, and changes the sign of the exponent to become positive. So we're going to do the same stuff that we were just talking about by multiplying common bases and adding the exponents, but then if we result in any negative exponents, we're going to change our answer by crossing the line and changing the sign. So first I want to look for any coefficients. So I see this 2 and this 2, so that means that I can add, or multiply them, not add them, multiply them to make 4. And then I look for the next variable, so I see x to the third, an x, and an x to the fourth. So remember that what we do with them is we take those exponents, remember this one has a power of 1, and we add them up. So this gives us x to the 4 plus 1 is 5, plus 3 more is 8. And then lastly I look and I see y is y squared, and y to the first, and y to the negative fourth. So I'm going to take and add those exponents. So this would give me 2 plus negative 4 makes negative 2. Plus, again, that power of 1 there, when I add them, gives me y to the negative first. But then, as we just mentioned, we don't like negative exponents, so this guy needs to drop down and change the sign of the exponent. So we have 4x to the 8th still on top, but now it's over y to the positive first. And that's all we're going to do because there's nothing else that could be simplified here. Alright, so we're going to do the same type of thing on the next question. We're going to look for any coefficients first. We have a 4 and a 3, so that means when we multiply them we get 12. I now also have an m to the negative 2 and an m to the first. So m to the negative 2 plus m to the first power, negative 2 plus 1, makes that a negative 1 on the exponent, so m to the negative 1. And then lastly we have n squared and n. So I take those exponents, that's an invisible 1, I take them and I add them, so 2 plus 1 makes that to the third power. But we cannot have any negative exponents in our answer, so this guy right here is going to drop down and change the sign. So 12 n to the third stays, and then that's over m to the positive first now. Alright, so cross the line, change the sign for negative exponents when you're all set with things. So I'm going to have you try these next two problems. So pause your video, try these two problems, and then check back in for your answers. So in this first one here, I have 3 times nothing else, so it just stays as 3. We have x times nothing else, so it just stays as x. And then y to the negative third and y to the negative first get multiplied, and then the exponents get added to become y to the negative fourth. This guy has that negative exponent, so we're going to drop it down, change the sign of the exponent. So the 3x stays up, and then the y to the fourth is now on the bottom with a positive exponent. So on this fourth one here, we have 2 being multiplied by nothing, so it stays as a 2. U to the first times u to the negative 2. And again, remember, all we're doing is taking those exponents, power of 1, power of negative 2, and adding them. 1 plus negative 2 gives us that negative 1 that we see right here. And then v to the second plus v to the fourth gives us that v to the fifth that we see. And then again, negative exponents must drop down, so this guy's got to drop to the denominator. And we are moving on to page number 3. So with this page, we're talking about something called the subtraction property. So when we are dividing numbers that have the same base, so same base being these x's, if we have division, what we do with the exponents is take them and subtract them. So now it becomes x to the m minus n. And again, our answer should only contain positive exponents. So there are some things with this that you have to recognize. You can move negative exponents first. Okay, so we're going to cross the line, change the sign first. Sometimes you want to wait till after, but in this case, I want to cross it first for this guy, because then I can just add exponents afterwards. Sometimes things like that are easier. I'm also going to divide these coefficients right away if they can be divided. And I'm going to write that note off to the side real quick for us. Divide coefficients. And then for this, I'm just going to write that little note, cross line, change sign. So now we have that 3 over negative 5 staying because nothing else can happen with it. The x on the bottom stays and so does the z on the top to the 7th. But now that z to the negative first goes up and becomes z to the positive first. So you can see that that's pretty much the only thing that has happened at this point. Then what I'm going to do is deal with this numerator. On this numerator, I notice that I have z to the 7th and z to the 1st. So I can take those exponents and add them, taking us back to the first set of rules that we learned. So we have 3 over negative 5x, but now here we have z to the 8th power. And then as I look across this, I have 3 times nothing more, negative 5 times nothing more, z times no other z's, and x times no other x's. So I've done exactly what I can do and as far as I can go. Okay. So we're going to take a look at this next one. I see negative 8 over negative h. Now this really is a negative 1 right here. So if you want to slide that 1 in there, then we can divide those coefficients. Negative 8 divided by negative 1 is just negative 8. Sometimes you don't, or positive 8, excuse me. Sometimes you don't have anything in the denominator in terms of coefficients, and that's okay. But I am going to take this guy with a negative 4th and bring him up top. So I'm going to write out what I already have, h to the 7th, j to the 5th, k to the 5th, over j to the 5th, and bring h to the negative 4th up, so now it has a positive exponent. So now I'm starting to look and I say, okay, 8 has nothing else to be multiplied or divided with, so it stays. When I look at these h's, I see h to the 7th and h to the 4th, so I'm going to group them and add their exponents because we're multiplying them up top. So that would be h to the 11th. I look for j's and I see j to the 5th divided by j to the 5th. That's just like 10 divided by 10. What happens with them? Well, they cancel. And then k has nothing more, so k to the 5th stays. So in this case, we just don't have a denominator. And that's okay, because remember, all we're doing is simplifying. Moving on to the bottom, we're going to stick together for these ones. If you want to try them on your own and check back in with the video, please, by all means, feel free. But we're going to stick together otherwise. So I'm looking at coefficients. 8 over negative 5 doesn't seem like it simplifies, so I'm going to leave it. I'm also going to leave everything else except for this negative exponent first. Okay, so that guy's got to drop down because it has a negative exponent. So we have x to the 3rd, y to the 3rd, x squared, z to the 8th, but then on the bottom we now have z to the 6th, positive 6 joining it. So I'm going to look across the bottom and look across the top. I notice that when I look at x's, I have x to the 3rd divided by x squared. So remember here we subtract exponents. When I look at z's, I notice z to the 8th and z to the 6th being multiplied, so here we add exponents. Okay, so you have to recognize those two different rules here. So we have 8 on top staying, we have y to the 3rd staying, we have negative 5 staying. But now let's fill in these gaps. We have x to the 3rd divided by x squared. So this right here, when we subtract exponents, gives us 3 take away 2, which is power of 1. So that is x to the 1st. Then when I do the z's, I have z to the 8th times z to the 6th. So 8 plus 6 gives us that power of 14 on the z's. And then it looks like everything has positive exponents, so we are good to go. It's okay to have this negative here. That's not an exponent. And then question number 4, take a look at your coefficients. 3 divided by 3 cancels, so you could put 1 over 1 if you prefer, but you don't have to. Take any negative exponents and move their location. Okay, so I have to do that with both r's actually. So we have p to the 6th, q to the 6th, p to the 8th, q to the 2nd, and then those r's swapped positions and changed their sign on the exponents. So now when I look at p's, I have p to the 6th and p to the 8th. They're being divided, so that means subtract exponents. So that would give me p to the negative 2. The next part I have q's. I'm also going to subtract their exponents because they are being divided, so that's q to the 4th. And then I have r's, subtract their exponents, so that's r to the negative 3rd. But now remember, our answer cannot have negative exponents, so we're going to drop these guys down. So that means we have q to the 4th up top still, p to the positive 2nd, and r to the positive 3rd. Now drop down. Another way to think about this one in particular, if I have 6 and 8 as my exponents right here, I know that it's going to be a difference of 2, and the bigger number, right here, bigger exponent of 8, means that I'm going to have the remainder of 2 left over in the bottom. Okay, so you could either jump from here down to the bottom process by knowing that, hey, the bigger number, the bigger exponent's in the bottom, so that means that I'm going to have p squared in the bottom. Or you could take the mini steps by just subtracting and then dropping down. The same thing applies to this piece here. R to the 4th divided by R to the 7th, you know that that's a difference of 3. And then because that difference of 3 weighs heavier in the bottom because there's a bigger exponent, then you know that R to the 3rd would be in the bottom. So either option's okay. You can take the mini steps or you can just take the big leap as long as you're comfortable with it. We just have one more page. We're almost done. Stick with me here. So this last page is just more of what we've been working on. So we can do these problems in one of two ways. I don't know if you've noticed it, but we can either move exponents first or we can just do the straight subtraction. It's totally up to you. But I do want you to recognize that there's a 1 here and negative 1/3 will not be reduced. So that will just stay as negative 1/3. And then I'm going to show you this in two ways. So option 1 is to just take these m's and subtract exponents. So it's 4 minus negative 3. That gives us m to the 7th up top. Okay, because I started on the top. And then we have q squared divided by q to the 3rd. So that would be 2 minus 3. So that's q to the negative 1st. And then p is just going to hang out down on the bottom because there was nothing to do with it. But now that q to the negative 1st can drop down. Okay, so we now have negative 1/3 m to the 7th, p, q to the positive 1st. Okay, so that's one method. The other method, let me just rewrite this, negative 1/3 m to the 4th, q squared, p, m to the negative 3, q to the 3rd. Okay, so this is just the same problem rewritten. So this is option 1 here, and this is option 2 here. Okay, because there are different steps that you could take at different times. So in this case, I might try to move this m to the negative 3rd up. So that means I would have negative 1/3 m to the 4th, q to the 2nd, p, q to the 3rd, but now m to the positive 3rd is going up. And then I finish the rest of the process the same way. So we would have negative 1/3, p stays because there's nothing else, m to the 4th, m to the 3rd. Now I add the exponents. So the difference is now in the rules, m to the 7th. We had m to the 7th before, but it was because we were just doing division. 4 minus negative 3, subtraction of exponents, gives us m to the 7th. So same answers, but it just is a different process because we decided to move the exponent up first. Then this right here gives me q to the negative 1st, but of course that would end up dropping down and giving us this answer overall. So there's 3 more problems I want you to try. Number 6, 7, and 8. And then I will check you check your answers with the video as I go through it. So in this first one we have 6 over negative 4. So that can be reduced to 3 over negative 2. And remember that you can do this in different ways. You can drop exponents or you can just straight divide first. So we have h to the negative 5th and h to the negative 1st. So negative 5 minus negative 1 gives us negative 4. h to the negative fourth. Right here I have j to the negative 2 and j to the 0, so this would give me negative 2 minus 0, which is just j to the negative 2. And this next one, k's 8 take away 7, because we're dividing the bases, we have k to the first. And then of course any negative exponents like these two force us to drop them down. So we have 3 over negative 2, k to the first stays, but then h to the positive fourth and j to the positive second comes down. And again, you might have started that problem by swapping across the line, change the sign, right? So, or we could have started with 3 over negative 2, drop the h to the positive fifth down, h to the positive first up, j to the positive second down stays with j to the 0, and then k stay where they were because they were all positive exponents. And then your process still would have been exactly the same. Take these, subtract. Now here we would be adding because they're being multiplied by one another. And then these get subtracted. Okay, so I'm actually going to let you try these problems now for questions 7 and 8, and then I'll go through the answers afterwards. Alright, so I've got my answers boxed in for these last two problems, but I'm going to talk you through it just in case you are struggling to figure out where I came up with these things. So first off, I took 2 and divided by 4 to give me that 1/2 right there. Then secondly, I took a look at the x values. So if I'm looking at x's, I have x to the second divided by x, or x to the negative second divided by x to the second. So negative 2 minus 2 more gives me that negative 4 here. And then I looked at my y values. Y, I have just y to the 7th, so that stayed. And then for z's, we have z to the 6th, and it's being divided by z to the negative first. So when I take those, positive 6 minus negative 1 gives me that z to the 7th. And then I recognize that this has to drop down. So that's the only change from this step here to this step here. Now in question 8, I chose to do it the other way, where I looked at, well, first the coefficients, that part stays the same. And then I took this x to the negative 8 and I brought it up. And then I took this z to the negative 7th and I also brought that up. So you can see that right here, z to the positive 7th now and x to the positive 8th, whereas everything else stayed. Then when I look at just the x's, these two are being multiplied, so I have to add the exponents to come up with the x to the 15th that you see there. And then the rest of it stays. Alright, so let us know if you have questions. Of course, I know that there are a lot of rules here. Maybe we can summarize them quickly together. We have x to the m times x to the n. So same base, different exponents, you add the exponents. If you have x to the m divided by x to the n, same base but different exponents, we have to subtract them in this case. And then if we have x to just some negative exponent, it crosses the line and changes the sign to become a positive exponent. So again, here we add, here subtract, here cross the line, change the sign. Alright, good luck with your practice. We'll see you next class.